Dr.SRIDHARAN from SNS College of Technology. In this lecture, we are going to see about the dry corrosion. So dry corrosion is nothing but chemical corrosion. So the corrosion it causes for industrial equipments, pipelines, and that is infrastructure. It causes material failure, economic loss, safety risk. So in this lecture, we are going to see about the understand the corrosion process uh, due to the dry corrosion and analyze, solve, and how to prevent from the dry corrosion. So in this slide, so the many applications coating and potential change, plating, and environmental modifications, and also the design improvement. So these are the some of the method to protect the material from the environment. So the real world problems, the engineers, especially for corrosion engineers, focused on the metal components and selection of material, and some cases metal compounds fail at high temperatures, surface damage without moisture, loss of material strength in industrial environment. So it is due to only for the atmospheric air. It contains the oxygen and other gases, mainly the metal oxidized within the oxygen molecules. Example from daily life industry: silver tarnishing due to hydrogen sulfide, iron corroding in acidic gas environment, metal parts in furnace and reactors. So some of the example here show in the slides. Direct chemical attack of atmospheric gas on metals occurs without moisture, common at high temperatures. Gas involved, particularly oxygen, and also hydrogen sulfide, sulfur dioxide, halogens, and acid vapors. The silver corrodes due to hydrogen sulfide gas, iron corroded in presence of acidic medium as well as oxygen. So here we focused on only for the dry or chemical corrosion. It is due to the oxygen molecule. The types of dry corrosion, that is oxidation corrosion. It happens by oxygen, and corrosion by hydrogen, liquid metal corrosion. Oxidation corrosion, the direct attack of oxygen on metal surface occurs in absence of moisture. It occurs in absence of moisture. Alkali and alkaline earth metals oxidize rapidly. Most metals oxidate at high temperature. Irrespective of the metal, at the high temperature, it happens frequently, oxidations. The oxidation mechanism for the metal surface: metal atoms lose electrons, formation of metal ions, that is M gives M2 plus 2 electrons. The real time application iron is Fe gives Fe2 plus 2 electron. And another side is reduction reactions. It happens with oxygen molecule. Oxygen gains electrons. That means O2 plus 2 electron gives O2 minus. The third step, that is a formation of a metal oxide. Finally we observed the metal oxide on the surface area. That depends on the metals or alloys. It may change the formation of oxide film. Oxide film growth observed on the surface area. Metal ion diffuse through oxide layer. Oxide film grows perpendicular to metal surface, leads to continued corrosions. The corrosion process is a continuous process. Is a oxidation. The continuously it happens for the oxidation process. Different ionic formations that related with the oxide films observed on the metal surfaces. The oxide film growth, there are three types: stable, unstable, and volatile oxide layer. That means stable oxide layer observed aluminum oxide, tin oxide, lead oxide, copper oxides, fine grained and adherent, impervious and protective, prevents further corrosion. That is a stable oxide layer. The best example is also the stainless steel is one of the best example. It a formation of stable oxide layer. That stable oxide layer that is in this case bilayer. One is chromium oxide and iron oxides. Unstable oxide layer decomposes into metal and oxygen. Corrosion does not proceed. Oxides of silver, gold, platinum. And third one, volatile oxide films based on the specific metal surface. It happens not for all. This is molybdenum oxide is one of the example for the volatile oxide layer. So the pilling petrol ratio is one of the measurements to understand about the stable formations or unstable formation. That means maybe productive and non-productive coating. The ratio calculated by volume of oxide by volume of metal consumed. It determines productiveness of oxide film. The productive there is a pilling petrol rule ratio less than 1, that is a non-productive. Pilling petrol rule ratio greater than 1, that is highly productive. So oxide layer is porous. In this case, the non-productive layers, oxide layer is porous, allows oxygen penetrations like alkaline earth metals and alkali metals like sodium, magnesium, calcium. Whereas the pilling petrol ratio greater than 1, that is highly protective. It's observed for heavy metals, lead, aluminum, copper, tin and surface areas. This oxide is a non-porous. So understanding of the corrosion basic principles and how to prevent the failures. Selection of metals depends on oxide behavior. The design thinking connects theory with the real world applications like coating, cathodic protection, anodic passivations, the pre-treatment, laser technology. So the different preventive measures we will discuss on next lecture. So assessment, the corrosion of metal involves physical, chemical reactions or both none. So here is corrosion metals. The corrosion of metals involves both. The corrosion causes economic problem, safety problem, both A and B. So some of the questions is very much interesting and based on the theory we can answer it for the all. You try to answer for all questions. References. So Wiley and Jane is reference books to make it for more concepts. Thank you.